This is a video about how to make a standard curve graph and get an equation for the line on it. This is going to be useful for the protein assay lab. So here I have opened up the protein assay lab assignment, and I'm looking here at question number 2 where it says create a standard curve for the absorbance data below. It says plot the A595, that's the absorption at 595 nanometers. Put those values on the y-axis. So all these numbers are on the y-axis, right? And that means that these concentrations are going to be on the x-axis. So I have my x-axis concentration, y-axis absorption values. And then draw a line of best fit. So to do that, I'm not going to do it with this data. I'm going to show you how to do it with some example fake data. So I've got my concentration here. If I wanted to label it more accurately, I could say this is my concentration in milligrams per milliliter. Take the time. You can probably add better details than I have in my example here. I select the data, including the headings on these columns. I go up to Insert, Chart, and it's going to make this chart. By default, it does a column chart, a bar chart. I can change that over here where it says Chart Editor and Data. It says Column Chart. Click on this triangle, and I can grab this and scroll down and pick other kinds of charts, line charts, area charts, columns, bars, pie charts. I don't want to make a line chart because the data we have are individual points. It's what they call discrete data, and we have non-discrete data, so we have individual data points. So scatter plot is what we want to do. So I went down and selected scatter plot. It gave me all these points. Now I can customize this graph. I click on the Customize tab here. I can change the chart style if I wanted to. I could give it a background color. I don't want to do any of that stuff. I could change the font if I wanted it to be in Tahoma font instead. I don't know. It doesn't matter. Charts and axis titles. If I wanted to relabel the title of my graph, right? I could say this is a comparison or a relation of percent absorption to whatever. I could percent A to const. I can change my title. You could do a better job than me, but you see how it changes it live right there. I could change the font, all those fun things if I wanted to. My next option, I click on series. So now I can put the axis on the left or right. That means the axis labels here, these numbers in this label, I can have them on the left by default. If I wanted to, I could move them to the right. I don't want to do that. My point shape are all circles. I could make them all like little stars if I wanted to. So there's all my points inside. That doesn't matter. That's just personal preference. You can do them different ways. I'll go ahead and leave them stars for now. This is where the most important box for us to hit here is, it says trend line. When I click this, see how it draws a line. It's drawing the line that best matches the data, right? So maybe this star happens to be on the line, but there's some stars that aren't on the line. They're just off, but the distance between these is going to be very similar. They tried to draw the best line they could to hit all of those dots. Now, here there's another box. When I get over here, it says show R squared. That's going to do a fancy calculation to tell me how good does that line match the numbers. When I click it, right, it shows here that my R squared value, R squared equals 0.99. That's really good. Any number above 0.9 is considered to be very good. So it's saying how good of a match is it. A 1.0 would be a perfect match. Every point was on that line. We don't have perfect match, but 0.99 is really good. And again, any number above 0.9 is going to be very good statistically for mathematics. More about that in other math classes for you guys. It's called a correlation coefficient. Now here, by default, let me go back. The default, the label for the line is just custom. I don't know what that means. I guess it's here. The default is it says trend line 4. I don't want it to say trend line 4. I want the actual equation of that line. So I'm going to say use equation. So now instead of saying trend line 4, it actually gives me the equation. And if you're familiar with the equation of a line, y equals mx plus b, well, y equals m, in this case is 12.1, times x plus b, in this case is 17.9. So I have an equation for a line. Y equals 12.1 times x plus 17.9. I have an equation there. So for any value of y, which would be an absorption value, I could calculate the value of x, which is a concentration that goes with it. Or Another way around, if I have a known concentration, I could go up and predict what the absorption value would be. So we can use this equation, y equals, and it doesn't include the y here, but that's the equation for the line. I can use that equation to solve some other answers. So I would take this graph, this graph here, I select this graph, let me get on here, select, copy that graph. So I think I just copied that graph. I'm going to try again, make sure I did. Go to my protein assay sheet here. It said I'm supposed to draw a line with the best fit and determine the equation. Control V. I'm going to paste this as unlinked so it doesn't change in the future if I modify my other spreadsheet or delete it. I paste it, so now it's just a picture. I can resize it. Notice how this picture includes the equation right there. So I have my equation. This is what you want to do for your data, for this data on question number 2. In question number 3, we're going to create a data table in class. We'll do that one together. And then use the equation of best fit from your standard curve. That equation here would be y equals, what's my m value? 12.1. 12.1 times x plus, what was that other number? 17.9. 17.9, right? And I might just write it like that, right? Get rid of that symbol. So that's my equation. So now I can plug numbers into this equation and either solve for y or solve for x. That's it. That's done. So when I'm done with it, I don't need this spreadsheet anymore. It's over. I don't need to keep this at all. Again, this data that I used was sample data. It's not the same numbers that you're going to use. You're going to make your graph using these numbers here. And that's it. Hopefully this video was helpful to you.